Thank you so much, Yash.
Welcome. Bus, Harshal, bus. Okay, guys, just wait for 3 more minutes and we'll start at 10:32. I'll just give a gentle reminder to all. So, guys, is anyone else? Prasanna is here, right? Prasanna, are you recording? Or, are you also recording? Cool. I'll tell you when to start so that we only cover the precise points. I'm sharing my screen. Do let me know if you're able to see the screen. Okay, all right. Is my screen visible to you all?
Yes,
And voice is also clear, right?
yes.
Sure. Cool. So we'll start in a minute. Just waiting for 10:32 so that if anyone is yet to join, they'll join. Okay. So Harshal and Prasanna, please do record this so that we do not go for re-repeating this. Okay, so let's start the chapter. So this chapter is chapter number 3, logical time. So before that, I covered chapter number 2 previous days ago, in which we were dealing with the physical time and how the events are working together. So first of all, why is the need of this chapter 3? Right? What was the sole purpose to come to this chapter along with? So this chapter is itself like the name of this chapter is yes, logical time, and the logical time it came up due to the reason I'll tell you. So let's start with this, and in either one or two slides you will be able to understand why we are going with the logic. Meanwhile, I'll also let you I'll also explain you some topics from the chapter 2 that are relevant to this particular chapter so that you are able to sync up with it. Okay. So basically, some theory about causality, and again the causality come into the chapter number 2 itself. So I'll tell you what the causality is. So basically, if there are two events, you understand what are events, right? So if I draw a process, I'm just drawing a process in front of you. So this is my one. This is my, I can say, process P1. This is my process P2, and this is my process P3. Okay, so these are called as this straight lines that I'm drawing. These are known as process P1, P2, and P3. So my generic process will be always be called PI. In this chapter also, when we'll be discussing, if you are encountering PI, you should understand this that particular I is the index of that particular process. So this is the process, and there are certain number of events that are happening in a process. Okay, and this is known as space time graph. So if I should not write it here, I should indeed write it here. So this is my process P1, this is my process P2, this is my process 3. I'm just discussing this from chapter 2, just giving you a brief of what we were discussing because it is needed. So these are three processes, and these white dots that I have created are events happening in each process. So this particular graph is known as space-time graph because this is working around the time and this is working around the space. Why space? Because each process will have its own memory. Okay, and why memory is coming? Because since we are dealing with distributed system, we are creating kind of software connectivity, and everything is related to data structure and all. So every data structure will require some space to perform actions, and hence this is known as space time graph. Okay, so this was the nutshell from the chapter 2. These white dots are event. There are three types of event. One is the internal event that happens internally for a process. One is the send event. So a message is sent from process P1 to P2, and this is, I can say, this is a receive event. Okay, this is the receive event of message. So there are three types of event that are internal, send, and receive. Okay, perfect. I hope we are ready with the theoretical background of chapter 2, and we can start from the chapter 3. So everything was working fine till then. In the chapter 2, we discuss about the physical time and why it is required, because we need to understand how the events are happening, right? If there is a function in our home, we need to keep a track of all the events that will be happening into that particular function or a process. But the issue with this was that we were using physical time. Now, since we were using the physical time, many a times due to process delay, like if you see in this particular graph, this message from P1 to P2 may have some abrupt delays due to any of the reason, and due to which the global syncing of the physical time was not actually possible. This is what is written here. I'm reading it for you. The concept of causality between events is a fundamental to the design and analysis of a parallel and distributed computing and operating system. Using causality is tracked using physical time. Okay, so causality, one more thing I'll highlight you here. What is causality? So if there are event, if I say there is an event A and event B, so this symbol or this symbol that has been drawn here, this is known as causality relationship. That means that B has like this signifies that B has occurred after A. So B is casually dependent on A. Until and unless A will give something, B cannot happen. This is what is causality defined. So if you see here, that causality is told here that usually causality is tracked using the physical time. Now, in distributed system, it is not possible to have a global physical time. I told you the reason. Correct. I'll tell you by theory also is written. As synchronous distributed computation makes progress in spurts, the logical time is sufficient to capture the fundamental monotonicity of property associated with the causality. Let us go further into this thing, what it actually means. Okay, so physical time, what is the physical time and what was the issue with it, I'll be describing in this slide. So physical clock tracks real time events, okay, real world timings, typically in terms of seconds, milliseconds, etc. Very normal that we are dealing with in everyday life. So they are used to measure actual elapsed time and synchronize time across different processes or machines in a distributed system. For this, what was happening? One, the system clocks that were present in the system, they were handling this thing, and other thing was network time protocol. This is kind of an important term because this may be asked into the MCQ. No, you like, we never know what can ask, so we should remember this. For physical time, NTP, network time protocol, was used to deal with physical timing. But now, what was the challenge with it? The challenge was physical clock was physical clocks can drift over time. That is, either they can run fast or they can run slow, and may not be perfectly synchronized across different devices or systems. This synchronization protocol, like NTP, aims to like dispense. But again, in a nutshell, this was creating some discrepancies and issues with handling of events with respect to the times. Due to this reason, we came up to the chapter number 3, that is known as logical time. So I'm able to get you to what the chapter is. So we had physical time prior, but again, this had some challenges due to which it was improvised to logical timing. Cool then. So what is logical clock in itself? So a logical clock are used to track the order of the events rather than the actual time an event has occurred. So what has been happening on the background? You must understand this. So like there are events happening. Okay, if I again draw the three lines over here to make you understand what I'm trying to say. So this is my process 1, this will be my process 2, and this will be my process 3. Okay, so my timing now will not go in such a way that it will go along with seconds or milliseconds. Instead, it will go whenever an event occurs. My time will increase by one, or my timing will increase by some certain value. So if this event one has occurred, my time I'm just taking a random thing at this moment to make you understand what logical time is. So even event has happened, so my time has started from 1 to 2. When this E2 happened, then it moved from 2 to 3. When E3 happened, it moved from 3 to 4. So logical time will not deal with actual time that is being playing role. It will deal with what all events have occurred, and then it will increment the timing according to the event happened. So in this case, the events can be tracked. We will see how it is tracked. So logical clock are used to track the order of the events rather than the actual time at which they occur. They are particularly useful in distributed systems because the processes runs independently and there is no such global clock that all the process can rely on. I hope this is kind of clear to you why logical clock and what logical clock. So example, so there are two examples provided here. One is this Lampert's timestamp, and second is this vector clock, and this will be described as further. So this Lampert timestamp, I can also call it as a scalar clock. Okay. So what it is in a very simple terms, it is a simple logical clock where each process maintains a counter that increments with each event. So what it means is each process, this is my process P1, this is my process P2, this is my process P3 to Pn. Each process will have one counter. This process will have one counter, this will have one counter, and this will also have one counter. Okay. So all this, what it will do, first an event happened, it will count by one. Event 2 happened, it will count by 2. This happened, it will count by 3. So each process will have their own local counters that it will be counting and proceeding further. So this is what is Lampert timestamp. It says a simple logical clock where each node maintains a counter that increments each event. When a process sends a message, it includes its current timestamp, and the receiving process updates its clock, blah blah blah. Whenever we'll be coming to this scalar timestamp and scalar clock, I'll be very detailed, like in a detailed way, I'll explain you what it is. And the vector clock is kind of a sophisticated way in which we do not see here what it is happening. We are storing it into 1D array, right? 1D array. But in vector, it will be n cross n matrix or n cross n array. This is the difference between scalar and vector. Again, this thing might look like tough or something, but when we will be understanding this today, it is very easy. Okay, chalo. Let's come to the introductory part. This chapter discusses three ways to implement the logical timing. The first one is scalar time, second is vector time, and third is the matrix time. Now, as per the like slides provided by sir and as per the course content, we will be only focusing on the two timings at this moment. One is scalar timing, and second is vector timing. Okay. Now, casuality amongst event in a distributed system is a powerful concept in reasoning, analyzing, and drawing inferences about the computation. See, why am I like rereading this line? Because this may be asked in kind of MSQs, right? We have fallen into the trap in data science paper. This all MCQs came up and we were not able to answer it very clearly. So this is why I'm keeping this as an important concept, because these small things may like create issues later. Other than that, the knowledge of the causal precedence relationship amongst the event of a process helps solves a variety of problems in distributed system, such as first point number one, distributed algorithm design. Second is tracking of dependent events. This is very important. We will like you will be understanding this in a nutshell. Third is knowledge about the process of the computation, and fourth is concurrency measure. Concurrency means if two events are happening in a concurrent manner, how it will be handled. So this all is handled using causal precedence. Chalo, let's move further to understand what is this framework of a system in logical clock. That means how a logical clock works in itself. Okay, so guys, kindly understand this very clearly, because this is kind of important term in itself. So system of logical clock contains different things. First thing it will contain is the t. This t is a time domain. This t is a time domain. I can say this will be a set of all the timestamps that are provided. Okay, and there will be a logical clock c. Now, elements of T will form a partially ordered set over a relation this. Don't worry, you'll be able to understand this. So it says the relation like less than is called the happened before or a casual precedence. Intuitively, this relation is analogous to the earlier than relation provided by physical time. So in chapter 2, when we were dealing with physical time, no, we were writing this a given B. This was called as earlier than or happened before that thing. So this relation is analogous. Analogous means similar. So the relation less than is analogous, or it is same to what we have studied in chapter number 2, which says something has occurred before this. So I'll make you understand further how the things are going. One more thing. Now, what is this C in itself? So, C is a function. What is this C? C is a function. And what this function is doing, this function is mapping an event in a distributed system to the element in the time domain. Why am I saying this? If you see this graph, if you see this graph, this E1 has an associated time event, right? Correct? Sorry, timestamp, right? The timestamp is it occurred at time unit 1. This has another timestamp 2. This has another timestamp 3. So what this logical clock is doing, it is mapping all the events to the timestamp. It is mapping all the events to the timestamp. As easy as that. Other than that, this logical clock is doing nothing. That's what is provided here. I'll bring this down so that it is because this will be used as reference. Yes. Perfect. Okay. So this is what is told. The logical clock is a function that maps an event E in a distributed system to an element in the time domain. There is a I can say there is a set of events that is happening, and there is a set of time domains. The set of events is denoted by capital H, as you can see in this. If you are able to say, I'm sorry. Yeah. If you are able to see this, it is gone. Where it is gone? Yeah. So this H is the set of all the events. जितने भी events होंगे for all the processes, that H is a subset. So H will contain how many elements with respect to this? If I draw this more, so this H will contain 1, 2, 3, 4, 5, 6, 7, 8. This H will contain 8 events. And what is this T? T will contain all the timestamp. So what C is doing? C is picking one event and mapping it to a timestamp. I hope this is clear to you all. Should I need to repeat this, or is it clear to everyone?
It's clear.
Clear, clear to all. Perfect. Let's go ahead. So this mapping has one condition in itself. Okay, and what is this condition is EI happens before EJ. EI happens before EJ. That means that event EI has happened before EJ. That this is the basic meaning of it. Very layman terms. That event EI has definitely been happened before EJ. And tell me one thing. Tell me one thing. अगर कोई इवेंट पहले हुआ होगा, so is there any timestamp, like the timestamp of that event will be definitely less than the coming timestamp, right? What I mean to say, if this event has occurred, if this event has occurred before ej, definitely the timestamp of event ei will be less than timestamp of event ej. Is it clear to all of you? Are you able to understand this?
Yes.
Yes.
Cool.
Go ahead.
So this is what it is told. And what is this? Again, one more thing to let you understand. This C of EI, what it is called? It is called as timestamp. Okay, this is called as timestamp. Timestamp is the unit time that is provided. It can be anything. Okay, so this is told here. If EI happens before EJ, that implies that the timestamp of EI will definitely be less than EJ. Understood this thing? Let's move ahead. The monotonicity property, the one we discussed above, is known as clock consistency condition. When T and C satisfies the following condition for two events, this one, EI gives EJ, double implies. Double imply means reverse is also true. If the timestamp of an event is less than the timestamp of other, definitely that event has occurred before another. So if both of the condition in reverse in both the direction is true in itself, it is known as strongly consistent. Are you able to understand this? What is strongly consistent? Perfect.
Can
No.
you please come again?
Yeah.
Yeah, okay, I'll come again. एक बात बताइए. Okay, this I'll give you some of the notations of mathematics here. This is known as implies. Okay, if I am writing ei gives, like ej, this implies that c of ei is less than c of ej. It means that if this will happen, then this will also happen. Understood this? But in this
Yes.
scenario, the reverse is not true. Means if c of ei is less than c of ej, then it need not to be true that ei has happened before ej, because it is single implies, it is going only in one direction. But now if I create this double implies, this means the either direction is true. Agar ei is happened before, like ei is happening before ej, that implies timestamp of ei is less than ej. Reverse is also true. If timestamp is less, then the event will be occurred before. Are you able to understand this double implies and single implies? Now you got to understand. I guess Sandeep and Atiksha asked, right? Guys, you are able to understand this? Okay, I take it as yes. चलो आगे बढ़ते हैं.
Yeah.
So if both of the situations are happening, then our situation or system of clock is known as strongly consistent. Okay, ये याद रखना strongly consistent, because when I will be dealing with scalar time and all, there will be some limitation in which this will be discussed. So do not forget this strongly consistent. Okay, so now we will be moving forward with implementing of the logical clock. How the implementation will be happening? So implementation of a logical clock requires addressing two issues. One is data structures local to every process and the protocol to update the data structure. Okay, so what the particular logical clock will be having, this will be having two things. One is the data structure. Why data structure? Because we basically need an array of timestamps to store. So data structure will definitely be required. And what should be the algorithm to increase that particular timestamp? That is called as a protocol. Protocol is basically, if I'm not wrong, protocol is a set of rules that are used to execute something. So there will be a protocol to update that data structure by any unit or by any condition, and the data structure will be required to store that value. Okay, so these two things will be required for implementing a logical clock. So now what will happen? Each process pi maintains data structure that allow it the following two capabilities. Yes, Kalpit, I hope today two recordings are happening. Yep. Let's move ahead again. Each process pi maintains a data structure that allows it the following two capabilities. Okay. Each process will have two capabilities. One is the local logical clock denoted by LC1, that helps the process pi measure its own progress. Okay. And the other is global logical clock denoted by GCI, that is a representation of the process PI's local view of the logical global time. Okay, I'll make you understand this thing. Okay, consider we are 27 students in this current lecture. Consider each of the people as a process. Okay, now in our future and LMS dashboard, we all will be getting our grade, right? Our grade. When we are proceeding with our course, we will be getting our updated timestamp. Okay, that Yash has completed this time, like this event, then he has completed this course, then he has completed this assignment. That is my individual tracking and individual progress that I will be like making sure and making taking care of. In my process, I don't feel like that anyone's intervention is needed because I am evaluating everything on my own. But other than that, also we have a community, I can say, scoring that is happening, like what other one has been doing. Okay, I yesterday put one example. I took two names, I'm taking that again. So there are two people, Harshal and Karan. So Harshal, like Karan's task is to deliver a message or deliver a item, and the Harshal's task is to receive it and like do other stuff of maybe something. So what two things are happening? So there is a process. Okay, one first process is the process of Karan to deliver an item. The second process is process of Harshal to receive that item. Okay, so they both will be maintaining their own local state at first. Why? Because at the end, Karan needs to ensure what items did he like sent, and even Harshal need to ensure what all items I received. So these two are local state. But if we take a broader view, we need to ensure what all things happened, what item did Harshal received and current sent to it. Okay, we need to keep a track of it also, and this is known as a global clock. You understand this? What I'm trying to say? Okay, so
Can you please come again? I just lost.
yeah, I'll say it. So basically, local clock is dedicated to each process. Each process will increment its own clock when event will be happening in that process. Okay, and global clock will contain the local clock information. Other than that, it will also contain the information of what has been received from other process. It will not Global clock will not only ensure the local system, but it will also ensure what all has been received or sent by that particular process or to that particular process. That is what I have written here, that the global clock not only keeps a track of all the events, all the local clock, but also keeps the information received from other processes. Are you able to understand this now?
Yes.
Yes.
So
Cool.
can we say that global clock has all the details of the all the local clocks, and
No,
no local
no. We
clocks
cannot say this. We cannot say
details?
this.
Okay.
Instead, what we will be saying that see, okay, I'll answer you just in 2 minutes. Before that, I should give one theory. So there are two things. Okay, there are two things here. One is LCI and GCI. This LCI is local clock to that particular process I, and GCI is global clock to that particular process I. So that global clock will be restricted to that process only, but it, see, देखो difference क्या है local clock और global clock में. Local clock will only keep in mind मेरे प्रोसेस में क्या चेंज हो रहा है, what is changing in my process. It does not need to ensure what am I receiving or what am I sending, or who is sending it to me or whom am I sending it. Okay, it will just ensure event हुआ या नहीं हुआ. Okay, but what global clock will do, it will keep the track of event
Okay.
happening, plus it will keep who sent that particular message to that particular process, or that particular process send a message to whom. It will also keep the track of it. You understood this now?
Yes. Yeah.
Cool.
Thank you.
Chalo. So the protocol ensures, I'm coming on this point. चल नहीं रहा, पेन कलर चेंज करना पड़ेगा. Okay, this one. The protocol ensures that a process logical clock and thus its view on the global time is managed consistently. For this, a protocol consists of a two rules. Guys, these two rules are very easy in itself. If you just give 5 minutes or yourself, you'll be able to understand this. Okay. So point number one, rule number one is the rule governs how the local logical clock is updated by a process when it executes an event. This is what updating a local clock is. That why I was explaining that if item is delivered, then that particular count will increase. This is rule number one. As soon as I am a process and Sneha is a process, as soon as I am doing an event, I'll update my process. I'll update my clock. This is the rule number one. And what the rule number two is, this rule governs how the process updates its logical global clock to update the view on the global time also. Okay. Why? Because if I am a process and Sneha is a process, if I am sending a message to Sneha, definitely the global clock of Sneha should also update that I have sent her something, and my global clock should also update that I have sent something to Sneha. So both the global clock should update to get the information of who sent and who received. Got it? So this is rule number one, and this is rule number two. It is very easy and in very limited terms. Okay, so I'll read it for you. Some due to some color issue this happened. So this is again what I told. This will be the replica of it. So it says, to maintain a consistency across the system, the logical clock must be updated according to the system's protocol. Okay, this protocol ensures that the clock satisfy the consistency condition. That is, the logical clock reflects the casual ordering of the events. So first thing, rule number one is update the local clock. What is the rule number one? Update the local clock. Each time a process PI handles an event, example sending it or receiving it or any internal event, it typically involves incrementing the clock reflecting changes of occurrence. So rule number one is update the local clock. Now, what is the rule number two? Updating the global clock. When PI interacts with the other process, it updates its global clock to integrate the information from the other process's clock. It might take involve taking the maximum of the current clock and global clock. Okay, this will be discussed later. But do you understood? Like you understood how this thing is working? Rule number one and two. Rule number one is, remember, rule number one is updating the local clock. Rule number two is updating the global clock. Cool. Shall we move ahead?
हम ग्लोबल क्लॉक को तब अपडेट करेंगे जब हमें कोई मैसेज रिसीव हुआ हो किसी और प्रोसेस से।
Yes, definitely.
और
And
हमने
in
सेंड किया हो तब भी
distributed system, number of events are happening, so it will happen on very frequent basis. But yeah, you are correct. Global clock will be updated when a particular send or receive message has been confirmed by a process. Got it?
कूल कूल।
Chalo. Guys, everyone, shall we start with scalar time? Yes.
Send and receive both will be saved, no? दोनों ही
हाँ,
record होगा ना,
definitely.
like sending and
Definitely.
receiving.
It's like our
Yeah.
WhatsApp message. When I send the message, I get a tick. When you receive the message, you get a notification. That is the thing. Okay. So
Okay.
my double tick implies I have sent. Your notification implies you have received. Okay. Chalo. Let's move ahead. Scalar time. I told you there will be two types of logical clocks that will be dealing. One is scalar time, one is and other is vector time. So we'll start with scalar time first, and we'll move for vector time today. So scalar time is used to assign. It is used to assign a unique value to each event, ensuring order and sequence of the occurrence of events. It was proposed by Lampert in 1978 as an attempt to totally order events in a distributed system. Okay, guys, what is total ordering? Okay, total ordering event says, where is my graph? Again, let me copy and paste it below. Okay, perfect. Done. So what I'm trying to say with this is scalar time is कहाँ गया? ये रहा. Okay, so it says total order events. Yeah, I was talking about total order, like ordering of event. It says for all the events that have occurred from P1 to Pn. Okay, all the events that have occurred from P1 to Pn, each event in that process should be in an order. Each process, not only E1, E2, E3, E4, En, but okay, but E1, E2, E3 of process 1, E1, E2, E3 of process 2, E1 to En of process 3, everything should be in an order. And this is what is called as total order of events. You understood this term, totally order of events? You understood this?
Yash, can you repeat again?
Yes, I will repeat. So totally ordering of events, what it is, see, for what we are doing for each process, we are keeping an order. Event 1 occurred, then event 2 occurred, then event 3 occurred, event 4 occurred. This was the local ordering. And total ordering means for all the processes, all the events that have occurred, they will be aligned into an order that is known as total ordering. Got it? Okay, let's move ahead. So time domain is a set of non-negative integer. Yeah, but obvious. The time cannot be negative. The time cannot be zero. Definitely, it will start from one. This is what is told. Now, important highlighting thing. The local logical clock of a process pi and its local view are and its global time are squashed into a single integer variable ci. So, what in scalar timing we are doing? The local time and the global time, we are squashing it together and we are making one integer value out of it. Okay, and this is how the scalar timing is working. Again, how the scalar timing will work, there will be two rules, and as simple as that, same as what we discussed just now. So rule number one is, before executing an event, the process pi execute the following. What it does is, the clock will increment the existing clock by a variable d. Okay. In general, every time R1 is executed, D can have different values. However, typically D is kept as 1. What I mean to say in this, where is my context? Here it is. Every time one event will happen, my global clock will increase by d. This happened, it will go by d. If at all this particular relation exists, again this will increment by plus d because this event happened. So this jumping of events by a variable d is basically rule number 1, and this d is kept usually as 1. We can have different values definitely, but usually typically d is kept as 1. So every time an event has occurred, it has occurred by a unit time. It is okay. Got it, guys? Rule number 1 understood?
Uh,
Guys, am I
D
audible?
can be
And
different.
are
Na?
you awake?
It's like sometime it can be one, sometime it can be two. So what if D have different values?
Definitely. See, this is not been provided in this PPT, and I'm not very much into distributed system, so I might not be able to answer you this. But as per what it is provided, D is usually kept 1, means that in most of the time we'll keep 1. If it has different values, maybe then there must be some synchronization or something might be happening on the background. So
Okay, okay.
I'll find the answer if you want,
No, no,
but
I just
this
want
is
to know what counts in a quiz.
okay. I'll mark it and I'll ask sir in Saturday class this question. Okay, so we all be getting this answer.
Yeah.
Okay, can any one of you tell me why d is greater than 0?
वही नेगेटिव
Guys,
नहीं हो सकता
calculate
इसलिए.
people यार, कोई तो आंसर दो.
टाइम है ना.
टाइम स्टेप नेगेटिव नहीं हो सकता इसलिए.
चलो नेगेटिव नहीं हो सकता तो 0 तो हो सकता है.
फिर वो सेम ही टाइम स्पेंड हो जाएगा.
सेम टाइम पे सारे हो रहे थे फिर.
Yeah.
Correct. Because if an event is occurring, it cannot occur, without any time. Time तो लगेगा ही लगेगा, भले ही 1 millisecond हो या 1 second. Time will always be applied. So that's why d should be greater than 0, strictly greater than 0. Okay, perfect. Now coming to rule number 2, this guys you need to understand it very very carefully. This is very important to understand how the rule 2 is working. It says each message piggybacks the clock value of its sender at the sending time, and this piggybacks means attaches. Okay, the meaning of piggyback is attaches. So each message attaches the clock value of its sender at the sending time. When a process pi receives a message with the timestamp c, it executes the following action. देखो, Let's draw it here to understand. I'm just drawing this again downwards. Yeah, कर लेता हूँ. Okay, guys, I'm back. So these processes are P1, P2, and P3. Okay, and how this is working now? That I have some events. I'll draw some events to make you understand. Again, E1, E2, E3, E4, E1, E2, E3, E4, and maybe E1 and E2. Okay, chalo. But yeah, so now I am saying I am drawing some relations. Okay, for understanding, I am drawing some relations here. So now what will happen? Okay, what will happen? Each time the I can say the event is happening, again the same thing, the timestamp will increase by one. But now, very importantly, understand this thing. Whenever a send event is triggered, or whenever a receive message is triggered, this E2 will send a message to E3, but there will be two things will be sent. First one with the data, or I can say not data, I'll write message, that will be stamp, plus the timestamp of E2. I can write it as C of E2. These two things will be sent to E3. Why it will be sent? Because if we want to maintain the order of total relationship, I know that at what time E2 occurred. Correct? So in this scenario, message will be gone, plus that particular timestamp of E2 will occur. So I'll write here to make you understand. The timestamp of E1 was 1, this was 2, this was 1, this was 2, this was 3, this was 4, this was 3, this was 4, and this was 1, and this was 2. Correct? ये हो सकता है because each process will having its own timestamp. Okay, now understand this thing. What I am and why am I trying to say? At E2, what is my timestamp value? Guys, anyone? At E2, what is my timestamp value?
2.
2.
2. So what will be the message that will be going in this? Sorry, along with the message, what is the value going? 2. Correct. So E3 will receive message as well as timestamp from where it is being coming. In this scenario, this particular E3 will have two values. One timestamp coming from the message and one timestamp of the local process. The timestamp coming is 2 and the local timestamp is 3. 3, correct? समझ में आ रहा है 3 this 3? Are you able to understand this?
Yeah, 2 timestamp. One is 2 and one is 3.
Correct. Two timestamp are coming. So now what it will do? It will pick the maximum of it. Okay, it will pick the maximum of it out of two, because the time cannot go in reverse direction. It will go in forward direction only. That's why it will take maximum. So what timestamp will be assigned to 3? It will be 3. You got it? समझ में आया ये? This is what is written over here, that each process, each message piggybacks. Now replace this word piggybacks with the attach. So each message is attaching a timestamp. You see, the message and a timestamp is been attached, right? And to sender at the sending time, when a process pi receives a message, when this process p2 will receive a message at c3, it executes the following action. It will get the maximum of either this particular local clock ci or the clock coming from the message. Whatever will be the message, it will update it. Understood this thing? Did you understood, guys?
Yes.
Yes. Just figure 3.1 shows. Okay. अभी ये rules for updating, again I have written the same thing. I'll read it very quick for you so that you understand. Again, the rule number one is, every time the rule number one is local, update your local timestamp first, then go for global one. So first rule is local event update. when it's applied before a process pi executes an event such as sending a message or receiving a message or any internal operation, it must update its own clock. देखो, here इसको मैं अभी हटा देता हूँ, and I have a data structure for it, right? I have a data structure for it. I am making the data structure here. Okay, when event 1 occurred, the value, as soon as the event 1 occurred, my data structure value got 1. Correct or not? Correct?
Yes.
Yes. Now, as soon as E2 will occur, first of all, the this particular local state of P1 will change, making it at 2. After that, what will happen is written below. Once it is done, so how it works? Before a process Pi executes an event, it must update its clock. The process increases its clock by a positive integer d. Typically, d is set to 1, meaning that it is incremented by 1 for each event. Ci equal to Ci plus d. And this ensures that the event within the process is assigned a unique timestamp and helps to maintain the order within the process. Fairly easy to understand. Coming up to the second rule. When sending a message, the process attaches its current clock Ci to the message. This value represents the timestamp of the message that was sent. And on receiving, it will again do the maximum of both. And once it is done, then the process then applies R1, incrementing the clock of D to reflect an event that has occurred. Finally, the process delivers the message, ensuring that the timestamp is updated. Understood this thing, guys? Clear hai? Ekdam? Just like water, clear? Okay, let's go ahead. So now there are some basic properties that we need to ensure for scalar timing. One is this consistency property. If you remember, थोड़ा सा slides पहले, I'll take you to ahead. There was written strongly consistent. You remember I told you that this will be an important factor later on. Just coming to that point only. Consistency property is scalar clock satisfy the monotonicity and hence the consistency property. For two events, EI happened before EJ implies timestamp of EI is less than timestamp of EJ. See, EJ, correct. This is correct. This is not a strongly consistency. This is only a consistency property because it is handling a particular direction, unidirectional. What is totally ordering? Scalar clocks can be used to totally order events in a distributed system, but the main issue that is coming in this is okay. So the main problem in totally ordering event is that two or more events may have happened in the same identical timestamp. This one I think you might have missed or you might have in your mind, but I'll say it again. Okay, the graph that I drawn here, एक बात बताओ, this event E2 has time 2 and this event E2 has also time 2. If these both occurs at the same time, to whom should I give the priority? Correct? Event of, I can say, I can write is P1 का event 2 and P2 का event 2, if both are having the timestamp of 2, right? If both are having the timestamp of 2, whom should I give the priority in ordering of total, in total ordering? Because in total ordering, each and every event will be tracked. So to whom to give the priority at first? So due to this parity, where it is, yes. So this was the problem. The main problem in totally ordering events is that two or more events at different processes may have identical timestamp. For example, in figure 3.1, the third event of process P1 and the second event of process 3.2 have identical timestamp. Just see this. Third process of P1, यार यहाँ पे 3 था, this was 3, okay, this was 3. So the third process of P1 and second process of P2 have identical timestamp in this situation, okay. And I guess Neha, you were asking, right? D can be any value. So in this D was 2, in this D was 1, okay. This happened. So again, the moral of the story was the third event happening in P1 and second event happening in P2 both have same timestamp. So to whom should I give the priority? Yes, Gitika.
Yeah, you just complete this and then I will ask.
Okay, perfect. No issues. So this is the scenario of tie. Why tie? Because two events have the same timestamp to whom to give the priority. So a tie breaking mechanism is needed to order such events, and a tie is broken as follows. Process identifiers are linearly ordered and tie among events with identical scalar timestamp is thrown on the basis of process identifiers. Okay, process identifier. Again, one important thing coming into the picture. I'll make you understand what this process identifier is. The lower the process identifier in the ranking, the higher is the priority. Chalo, theek hai. Let's come to this process identifier. So basically, process identifier is a identification value or identification entity of a process. Okay, this process identifier can be anything like MAC address, UUID, process number. So usually, or for our understanding, we take it as P1, P2, and P3. So what is the process ID for P for this process? 1. What is the ID for this? 2. What is the ID for this? 3. This is the process ID. This is a unique identifier. Okay, and understand this point. Why is it coming into the picture? Because in this situation, in this scenario where the figure was 3.1, let me take you to that. Yes, 3.1, the process identifier for P1 was 1, the process identifier for P2 was 2, and the process identifier for 3P3 is 3. Now, in this scenario, if there are two tiebreakers for what values, this value and this value, we will see their process identifiers. What was the value of process identifier? And the lower process identifier value will get the priority first. Or, in other words, I can say the process having lower identical value will happen before. That means the priority will be given higher to it. And that's what the point is here. The lower the process identifier in the ranking, the higher is its priority. Did you understand this point? Did you understand this tiebreaker scenario? Perfect.
No,
No.
explain it also.
Yes, yes. अच्छा देखो again. This issue occurred. देखो issue तो आ गया. What was the issue? That there were two processes that were happening on the same time. Okay. Now to whom to give the priority? It was just a matter of priority. Okay, so to check the priority of it, we came to the point that we should go for third variable to check, right? Just say usually it happens that if there is a tie breaking scenario, we look for third factor which is greater and then we give the priority. Similarly, in this, the third factor is the process identifier, and I have given that for process P1 the identifier is 1, process P2 the identifier is 2, process P3 the identifier is 3. So if there is a tie breaking scenario situation in this process, this and this, I will go for process identifier. Now tell me one thing, Sneha, one chota hai ya two chota hai? Very basic question, like one chota hai, right? So in this scenario, since one is small, I'll say the priority of the process of the event happening on one will be more. And hence the event 3 of process 1 will occur before event 3 of process 2. Understood this? Cool. So, the timestamp of an event is denoted by tuple ti, t, comma I. What is this? The tuple is the timestamp. भाई जो t है, this is a timestamp. And what is this I? This I will be the unique identifier or process identifier. Why am I sending this as a tuple? Because I'll say if my t is different, then take t as consideration of priority giving. But if in case t is same, go with I. Check what is the identifying value. If it is greater than or less than, and then make a judgment to whom the priority should be given. Okay. So this timestamp has a denoted by a tuple ti, where t is the time of the event occurrence and I is the identity of the process where it is occurred. A total order relation on two events x y with timestamp h comma I. H is h comma I and k comma j. अभी h and ये क्या है guys? What is this h and k? H and k are timestamp. Remember this. H and k. This h and this k. They both are timestamps. And what is I and j? I and j is basically process identifier. So the total order relation, this symbol is the total order relation. So the total order relation on two events x and y with timestamp hi and kj respectively is defined as x is in total order relationship with I, double implies h is less than k, or if h is equal to k, then I should be less than j. देखो बहुत easy है, बहुत easy है. Understand this. Tell me one thing. What is h and k? What you understand from h and k? What is this? Can anyone help me with this?
Timestamp.
Timestamp. Correct. This h and k is timestamp. Here, why we are learning this thing? ये आया ही क्यों? Because the problem occurred when there were same timestamps, right? So due to this, so point number one is x will be in total order with y if h is less than k. फिर तो अपना problem solve ही है. If h is less than k, this says that the timestamp h is less than timestamp k. So basically priority will be given to h. Correct? But or in this case, if both the timestamp are equal, then definitely my process identifier I should be less than j. Then only I will say x is in total order relationship with y. Did you understand this thing?
Yes.
You understand? Okay. Guys, everyone understood this? Okay, perfect, 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 perfect. And this is double implies. This is going in strong consistency. Okay. So I hope you are able to understand this. I'll just erase it to reduce reading issues. Okay, now let's come to event counting. Okay, again very easy. These all are properties that we are understanding. Okay, event counting is very easy. Tell me one thing. If I'm incrementing each event by 1 unit, so can I say that if for event E, if I have timestamp h, okay, for an event E, सोच के देखना, okay, for an event E in a process, this is my process, okay. This is my process and these are my events E1, E2, E3, E4, E5, E6, E7, E8, dot 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 dot. Okay, so if I am talking about ek, right, for any event k, what and having a timestamp, having a timestamp h, or I should not write this k to like convey like confuse you. If there is an event e having a timestamp h, tell me one thing, how many events have been occurred before it? Can anyone answer this?
E h minus 1.
Yeah, definitely h minus 1 only, not e h minus 1. H minus 1. Okay, e h minus 1 will be this event, Sneha. Okay, this will be e h minus 1. This will be if this is eh. Okay, what I am trying to say, if an event has a timestamp of h, then definitely uske pehle h minus 1 events have occurred. Why? Because each event is taking 1 unit of time. So I can say numerically, if I say if an event has a timestamp of 10, definitely 9 events have occurred before. Correct? Is it true? Understood this all? Correct. So this is what I am trying to say. So in a generic way, if h is my timestamp of event e, then h minus 1 events have occurred before, and this is what is called event counting. If the increment value d is always 1, then the scalar time has the following interesting property. If event e has a timestamp h, then h minus 1 represents the minimum logical duration counted in units of event required before producing an event e. That's it. Got it? And this particular e will be called that it has a height. It will be called it has a height of h. Okay. So if I ask, tell me, like you answer me, what is the height? What is the height of? Okay. What is the height of event E100? What is the height?
99.
99.
Perfect. Correct. So the height is h minus 1. In other words, h minus 1 events have been produced sequentially before the event e regardless of the process having. For example, in figure 3.1, अभी आप मेरे को देख के बताओ, ठीक है? This is my point B. What can be the height of B? Just see the graph and tell me. If you want, I can zoom it for you.
6 होगी क्या?
Someone is saying 6. Okay. Other than that, is anyone with another answer? or should we log this as final? Guys, come on.
Path.
Okay, 5. Any other answers? Prasanna, 5. Okay. Okay. So why 5 and why 6? I'll tell you. So let's count the event number of event happened before B. So this event happened 1, 2, 3, 4, and 5. We will not count the bth event because that won't be the height of it, right? That is the thing. So 5 events have occurred. So this is the case. So in figure C, 5 events precede event B on the longest casual part ending at B. Understood? Okay. So now the system of scalar clock is not a strongly consistent. That is, two events EAIJ says that if the देखो भाई ये बहुत ध्यान से सुनना ठीक है. If C of EI, or I can say timestamp of EI is less than, if timestamp of EI is less than timestamp of EJ, that does not signify that EI has happened before EJ. Why? Because सुनना एक minute, right? Just understand this particular graph. 1, 2, and 3. 1, 2, 3, 4, 5, 6, 7. This is the thing. Okay. So I'll say it 1, 2, 1, 2, 1, 2, 3 timestamp. Okay. Now tell me one thing. ये वाला timestamp से छोटा है. Correct है? I am saying, if I say it as x and I am saying as y. So C of x is definitely less than C of y. Any double like any double thought in this? Fairly simple to understand. Okay, but but is anyone able to convince me that E has occurred before, like, sorry, 1 has occurred before 2, or I can say X has occurred before Y? Does it symbolize this fact? अगर टाइम स्टैम्प छोटा होता है तो कैन वी कंक्लूड दैट दिस इवेंट हैज डेफिनेटली ऑकर्ड बिफोर दैट?
नहीं भाई, कोई
No,
रिलेशन ही नहीं
definitely not. Because there is no relation between both of them. So how we will be able to justify this fact? That's why it is written that even if the timestamp of EI is less than EJ, that does not say that EI has happened before EJ. Understood this thing? In figure 3.1, the third event of P1 has smaller scalar value than third event of P2. However, the former did not happen in later. That's what this diagram says. Okay. Now, what is the reason behind this? So the reason is that the scalar clock is not strongly consistent, is that the logical clock and the global clock, they are both squashed into one particular integer. Due to this, the loss of casual information among the event is happening, and this is the reason why we are not able to justify which event occurred before and which event occurred later. You guys understood this thing? Understood this thing? Chalo, perfect. This is the end of scalar timing. So the scalar timing story ended with a post credit that there was a limitation in scalar timing to handle the total ordering due to loss of information of which event occurred before and which event occurred later. Are you guys able to understand till this?
Yes.
Okay, perfect. Just give me a minute. Okay, chalo. Let's move ahead. So now coming to the vector time. Okay, understand this. This is easy. This is not tough, but this is relatively tough. Okay, so the system of vector clock was developed independently by Fitch and Matron and XYZ. Okay, none of the matter. But in the system of vector clock, the time domain is represented by a set of n-dimensional non-negative integral values or vectors. देखते हैं भाई क्या होता है. ठीक है, लेट्स अंडरस्टैंड दिस अगेन. P1, P2, P3, P4, and P5. Okay, understand this very carefully. Abhi tak, till here, what we were doing, we were just storing single array and updating the value one by one, one by one, one by one. Correct? But when we come to vector, it becomes an n cross n matrix or n cross n array. That means if there is an event E happening here, let me use different color. If there is any event happening E here, this will have okay, this will have the matrice in a format. Okay, what it will have, it will be having 0 0 0 0 and fifth process 0. So this is 1 cross 5 matrix, right? 5 rows and 1 column, 5 cross 1 matrix. Okay, correct. Every process will have this value. And again, let me give a broader view of it. Okay, what it is. Okay, this is understand it very carefully, guys. Very easy to understand. एक बार बस ध्यान से सुनो, बहुत easy है. This is timestamp of P1. ठीक है? This is timestamp of P2. This is timestamp P3. This is timestamp of P4, and this is timestamp of P5. Okay. Tell me one thing. If I say I have 50 processes, what will be my matrix in this case?
50 cross 1.
50 cross 1. Correct. And each row in it will be equivalent to timestamp of that particular indexed process. Got it? समझ गए आप? Perfect. So there you go. Now I made this 5 matrix to make you understand broader view. But when we'll be dealing ahead, I'll just remove it to make it easier for you to understand. Okay. तो देखो, एक चीज का ध्यान रखना आप लोग सभी कि 1 2 and 3. So since this is 0 0 0, and I told you that time cannot start with 0, time should be greater than 0 only. So each initial process will have its own value as 1. So this will have 1 in itself. The second one, I'm writing this here, this will be 0 1 0. And can you guys tell me what it will be?
001.
001. Perfect. 001. ठीक है, आप समझ गए. And this is the reason why it is becoming n cross n matrix, because ये तो ये हो गया and events भी आते जाएंगे, आगे बढ़ते जाएंगे. So to accumulative it will become an n cross n array, n cross n matrix. Understood this? This is called as vector time. This is called as a vector timestamp. Okay, understood. Chalo, perfect.
Can you explain once again? It's not clear to me.
Perfect. Chalo. See, you understood these 3 processes, right? So what we are doing and why we are doing, first of all, what we are doing, we are creating a, I can say, matrice. Okay, and matrice will be n cross 1 in this case, and n will be 1 to n, and each value will be corresponding to that particular process. So first one will be corresponding to timestamp of 1, second 2, third P, 3 4 5. You understand till here, Atiksha?
Yes.
Okay. Now I told that none of the process can start with 0 timestamp. It was clearly explained very clearly that timestamp should be greater than 0. Okay. So each process will have its own initial value as 1. So for process P1, the first value will be 1, other will be 0.
Okay. Now it's clear.
Second is 1 and third is 1. Understood? Chalo,
Yeah.
बात जाते हैं. In the system of vector clock, the time domain is represented by a set of n-dimensional non-negative integral values. Fairly clear. Each process Pi maintains a vector Vti 1 to n where VTI is the local logical clock and describes the local time progress of PI. ठीक है. VTJ represents the process PI's latest knowledge of PJ local time. If VTJ is equal to X, then process PI knows that local time at PJ has ये. देखो ये अभी अभी आपको शायद समझ में नहीं आएगा because I have not given you the intuition behind it. As soon as I will come on this particular कहाँ गया ये वाला when I am coming this on this thing, definitely the moment you reread this you will be able to understand each of the thing. Okay. So do not fall into this all the variables because everything is variable. V, T, I, J, P, I, X. Everything is variable. So we are not able to concentrate on a single value. So in this case, I'll go further and I'll make you understand what I'm trying to say. So again, as in scalar clock, there is a as in scalar clock, there were two processes, P1 and P2. In the same way, there will be two processes in the vector clock also. Rule number one and rule number two. Same to same, nothing difference. First of all, update your own local clock so that VTI will be VTI plus D. And second one, again same. Find the max of the two. One is coming and one is the local. Find the max of both. Whatever you get, execute that particular R1 again. Because now, since you got this, you are able to do this, but again you need to update your local clock also for that second process. So that is why it is written execute R1 and then deliver the message. Okay, the timestamp of a event in the value of the vector clock is executed. Figure 3.2 shows, okay, initially the vector clock is 000. सबसे पहले the initial, the very basic thing will be 000. As soon as the process will start, it will start to be 1 2 3 4. Okay, and this is the understanding. I'll make you understand. We'll read along with this thing. Vector clocks are more sophisticated way of tracking time and causal relationship between a distributed system compared to a scalar clock. They provide a mechanism to capture the partial order of the events across multiple processes, addressing the limitation of scalar clock. This is the main thing to understand. Okay, key concepts to understand. One is time domain. You got to understand what is time domain. Okay, the time domain is represented by n dimensional vectors of non-negative integer where n is the number of process. Each process pi maintains its own vector clock known as vti. So if I write vt1, that means this is the vector time. I'm writing for you so that you understand it. Vector time for process 1. Got it? Second is vector clock structure. VTIJ, the element and index j in the vector clock, represents the latest known logical time of PI. This is basically explanation of the previous one only. And local time. I'll explain you with an example. This is more good. Okay, initialization. For each process PI, initialize the its vector VT. All the elements are set to 0. For the system of three processes, the vector clock P1 might look like 000. Event occurrence. When an event occurs at a process Pi, it increments its logical clock by 1. So, if an event E occurs at P1, that particular VT1 will increment by 1 and the array will be 1, 0, 0. ये जो मैंने आपको बताया था 1, 0, 0. You understood this 1, 0, 0 now? Understood this?
यानी P1 पे एक local event perform हुआ है.
Yes. At any place the event occurs, that particular process will increment by 1. So guys, tell me this thing. What will be this value? Just tell me this. What should I write here for E2?
200.
Perfect.
200.
Perfect. Chalo, बढ़िया. I'm able to understand that you are understanding. Okay. Now message sending. When a process Pi sends a message to Pj, it includes a copy of a vector clock. देखिए, scalar clock में क्या हो रहा था? Data के साथ scalar timestamp we were sending. What is happening in vector? Again, we are sending the vector time with it. Then it includes a copy of its vector in the message. For example, if P1 sends a message to P2, it might send the vector clock VT1 2, 0, 0 along with the message. Right? Message receiving. When a process Pj receives a message with the vector clock VTM from a process Pi, it updates its own vector clock. For each index k vtk maximum वही maximum निकालेंगे and then हम we will update it in that particular global clock. Okay. And example, understand this example, एक बार ध्यान से सुनिएगा. Consider the three process vector clock 100, 010, 001. Now event is happening at process p1. When p1 performance event, it increments its own clock and vt1 becomes 2 comma 0 comma 0 that you told. Okay. Now the message passing from p1 to p2. So when p1 sends a message with that particular vector time to P2. That means along with the data, this VT1 is being sent to P2. What will happen? This P2 will receive the message, and on receiving the message 2, 2, 0, it will combine it with its own clock and it will update it as 2, 3, 0. ये आपको अभी theoretically लग रहा है. In this graph, it will be clear to you. Just one slide more ahead. Okay. So advantages of vector clock, that it captures the causality. Unlike scalar clocks, vector clocks can capture the causal relationship between the events across the processes. It prevents overwriting and it solve the conflict detection. Like sorry, it like detects all the conflicts. But again, there is a very tremendous or like amount of space that has been taking up. Why? Because n number of processes will be there and n number of events will be happening in this. So you can understand how large value of like array I will be happening. Maybe 1000 processes are happening together, and each in each process maybe more than 1 lakh of the events are happening. So do you understand the complexity of space in this situation? So this is the major drawback what vector brings up. And again, there will be a solution of it. I'll discuss in just 5 minutes. But before that, I should explain you this diagram. Okay, guys, are you able to understand it till here? I just need a feedback from you so that I will be able to proceed further.
Yes.
Okay, perfect. I hope the rest are also getting understand. See this process P1. This is clear to everyone, right? This is clear to everyone. 1 comma 100, 010 is also clear to everyone, and 001 is also clear to everyone. Now what is happening after that? This event occurred, and hence the process p1. Yes, Harshal, your point may be valid. So for a process P1, if event 2 has occurred, my 1 will be incremented by one value, it will be 200. Understood? अभी बहुत ध्यान से सुनिएगा सब लोग. Okay, it is very important this time to understand. When I will be sending the event to second process, this 2, 0, this 200 will be sent along with that particular message. And now this P2, this P2 will update its local clock on what parameter? On the second parameter. On the second, I can say row only. Okay, so it will increment since this event has occurred. Since this event has occurred, this value of 1 will be incremented to 2, and it will see maximum of P1 for this and P1 for this. Okay, so in this scenario, एक बात बताओ, यहाँ पे my P1, yes, my P1 of 1 was 2, and here P2 of 1 ये क्या था? What was it? It was 0. Correct? 0 था ये. Correct है? So what should it select? 2 or 0? It will select the maximum of it. So it will select 2. Hence you are seeing here 220 instead of 020. Understood this? Understood this? Everyone, 22 people. I know this is late, but
Yes.
just few time more. Again, coming to this next node, one more event happened in process 2. That's why it became 230. Again, one event 240. Now this 230 is passed to this particular event. Okay, so this event is having 230 coming from the message, and from the local time it is coming 0, where it is this, it is coming 0, 0 and 2. Why 2? Because the process had increased. Okay, now what will it do? It will update maximum of this and maximum of this, and hence you are getting 232. this one. Understood this? Fairly easy. Correct. And hence 233, 234, 434, everything will be working in the same process. I'm not going more than it because I want, honestly, I want you to get the intuition of it on your own. If you are able to understand it, I will mark my it as my victory. If not, then I'll definitely have a conversation with you on this. Okay? Understood this flow? In this case, what is happening? Since देखना एक चीज देखना है ना, एक चीज यहाँ पे this is important to understand. Since I got my value as 2 here, since I got my value as 2 here from 0, I know that from process P1, event 2 was triggered, event 2 triggered my particular request, right? If this value is, see, again, if this value is 5, oh, okay, not this one. I can say this one. If my value is 4 here, what does it say? It say that the fourth event from maybe some process is bringing some information to me. Fourth event. And if you see this here, one event, two event, third event, and fourth event. Is my theory correct to you? Yes. So fourth event is happening. So in this case, I can determine the causal dependencies and causal relationship. This problem is solved. That was happening in scalar timing. Are you guys able to understand this thing? Everyone? Perfect, perfect, perfect. Chalo. Ha. Now some small theory to understand that, again, properties of it. So it says that VH and VK, they are basically two timestamps, nothing other than that. Okay. So if it says if the two timestamps are same in a vector, understand this. This is very important. Scalar में हमने समझा था. Let's discuss it in vector. 230 and 230. Okay. This is my VH and this is my VK. Correct? So VH is a timestamp, VK is a timestamp. If these two timestamps are equal, okay, if these two times of equal, then definitely I should, then if definitely each of the rows for them should also be equal. That means 2 should be equal to 2, 3 should be equal to 3, and 0 should be equal to 0. If each and every row is same to each other, then we can say VH is equal to VK. This is the first point. Understood this thing? So VH of X is basically VH of 0, VH of 1, VH of 2. Now coming to the second thing. VH less than equal to VK. VH less than equal to VK का क्या मतलब है? I'll tell you. कहाँ है? कुछ लिखा है क्या मैंने? नहीं लिखा. Okay. No worries. Yes. So VH less than equal to VK का मतलब ये है कि अभी I'll be discussing, I'll be writing it as I and J. I represents elements of this, J represent element of this. So if I'm saying timestamp VH is less than equal to VK, that means I say for all I and J, I should be less than equal to J. Understood? This means that 2, 3, 0, and if I write 4, 3, and 1, this relation holds correct. Why? Because 2 is less than 4, correct. 3 is equal to 3, equal to sign, correct. And 0 is less than 1, correct. So I can say VH is less than equal to VK. Understood this thing? Understood this thing? Okay. Now comes to strictly less than. VH strictly less than VK. This says, this says that VH is less than equal to VK and there exists at least one index where it is strictly less than K. That means I am saying that ये जो situation है देखो, this also comes into the category of I less than equal to J, correct? It follows this thing. But if I want to say I less than J, then what I am trying to say that in sub में से there should be only at least one value that is smaller. That means if I write here 230 and if I write here 330, so even though they both are same, I have at least one index where 2 is less than 3, and hence it is known as strictly less than. That's what it is trying to say. Understood? Perfect. and VH is concurrent to VK. It says neither of these are related to each other. मतलब देखो, मतलब ये कहना चाह रहा है, if I write कैसे बताऊँ उसका example, कैसे बताऊँ I should write something.
So, हाँ ठीक है.
Okay, so in this scenario, it is not strictly less than or strictly greater than. Why? Because चलो इसका मैं एग्जांपल आपको कल व्हाट्सएप पे भेज दूंगा. आई हैव एन एग्जांपल विथ मी बट नॉट एट दिस मोमेंट. आई थिंक आई हैव इट. आई शुड सी फॉर इट जस्ट अ मिनट. Yes, 234 and 315. Okay. So in this case, the first timestamp is not strictly less than the second timestamp. Correct? Why? Because there is no such value. Correct. And again, the second timestamp there is not strictly. So they both are not strictly less than or greater than. That's why we say that they both are concurrent in nature. Understood this? And this is what I have explained this here also. Nothing more than that. Just coming to the last thing, strongly consistency. Yes, it is strongly consistent because now it is working in the both direction. If EI is happening before EK, since we have the count of it, we are able to justify that the event is occurring before it if the timestamp is less than the other timestamp. So our that problem is solved. Again, event counting is the same. क्या इवेंट होगा, what is the number of that particular index? If I have 5 comma 0 comma 1, that means 5 event have occurred in process 1, 0 have occurred in process 2, 1 has occurred in process 3. This is what is called as an event counting. Okay, and height is again the same. Now the drawback is that I told you. What was the drawback of it? The drawback was heavy computation due to n cross n array and very large space complexity. To reduce this, an optimization came up that was known as single Semi-Kalyani differential technique. Okay, this is again 5 slide. Now, guys, you decide and tell me: should I continue today or should I take it some other time, maybe tomorrow? Guys, quickly, can you let me know?
Today.
Yes, tomorrow. Tomorrow.
कल ही
Yeah,
कर
guys.
लेते हैं यार.
If you are awake, please respond me so that I can be clear in this. Tomorrow. Perfect. Perfect. So I guys, okay. Today, since we had a repetition of the concept, that's why I was not able to complete this. But I hope you are able to understand everything till here, right? Vector वाला भी समझ में आ गया सब लोगों को? Okay, perfect. Chalega. So this like this one, it is very easy in itself. If you want, rather than me explaining it, I have referred to a YouTube video, and that YouTube video, trust me, it has the same PPT that we have seen. Okay, that particular YouTube video, it is of a professor from BITS Pilani, from Hyderabad campus. He has taught this algorithm, and he taught it so beautifully that I was able to understand in a minute. So, is it okay if I share you that YouTube URL and you are able to understand it from there? So I can mark this chapter as end right now, or I should take it tomorrow.
अगर डाउट आता है तो पूछ लेंगे आपसे. वो
Yeah, video will be fine.
Video will be fine, correct? Yeah, because you can listen to it also again and again. So I'll share the YouTube video in the official group or maybe unofficial group wherever you need, and that will be helpful. And if this is so, then I mark this unit as chapter as the completion. Okay, this is the last thing that was yet to be discussed. So chapter 2 and chapter 3 are completed. Guys, let me know if you have any doubts in this topic till now.
Yes. Then that scalar clock
Hmm.
is just asking that when we are sending the message,
Hmm.
can you share that slide, that diagram we were discussing?
Oh,
So it's okay. Like I can explain. Like in process one, we are at
see
event two.
this one.
Yeah. Scalar. Mm-hmm. where we are just sending the message,
Hmm.
C message.
Hmm.
Not this one. Okay,
This
let's find. Oh, okay,
this,
it's fine.
this is only scalar time.
Yeah, yeah, yeah. So here on event 2, the local timestamp is 2.
Hmm.
Right?
Correct.
And no, not this one. That C message thing. Yeah, yeah, yeah. Yeah. So just my doubt was like when we are at process 2, okay, and there we are at event 3.
Process
Okay.
to an event 3. Okay.
Uh-huh. And then process 1, event 2. So what value we will send? Like C message will come to, and here it we will increment it by 1 and then we will compare. Right? That's what we are saying, na?
Yes.
That first we will increment the local logical clock of process 2, and we will have the local logical clock of process 1, and we will compare both.
Hmm.
My only concern is coming, we are incrementing process 2 clock before
Hmm.
comparing. Okay, we have incremented 1,
Hmm. Hmm. Hmm.
but from process 1 we are taking the same clock. Why we are not incrementing it and then we are comparing? Did you get what I am thinking?
Yes, I got it.
Hmm.
See, this event 3. Okay, what is this event? Tell me one thing. क्या काम
Even
कर रहा है ये? क्या काम कर रहा है ये?
like anything, like any event is happening
No,
there.
it's not anything. It's very specific to receive an event, receive a message.
Mm-hmm.
Nothing more than that. It is very restricted to receive a message. This is very restricted to internal state change. This is very restricted to send a message 4-1. But what this 3 is doing, its task is to receive a message. Okay. So until and
Mm-hmm.
unless it does not receive a message, will you call it as event done or event happened?
No.
No. So after the event has, after the message is received, then only you will say, right, in that process too, that event has occurred. Correct.
Yes.
That's why first we complete the event and then we increment.
So that is why you are saying when it has received, so the timestamp came as 2, right?
Yeah, right.
Then the
There you go.
event 3 was like on process 2, and it was a receive event. So for receive event it incremented so when it will increment, the value will become 1 plus 1, that becomes 2, right? See,
Yeah,
process 2
yeah, yeah,
logical
correct, correct,
logic
correct, correct.
at 1.
That's what I like conveyed to Sneha also. Sneha asked one doubt, that is D only always one, right? Is D always one? So I told that it may change, and this is how
No,
it
that
is.
is fine. The D is 1 only. I got it. But 1 plus 1 it becomes 2 here.
That's
Okay.
what I'm saying. That's what I'm
Mm-hmm.
saying. If you see this, D
Mm-hmm.
can have different value. However, typically D is kept as one. So that's what I was saying, that timestamp they increase by 2 in this scenario. Here they increase by 5 in this scenario, right? You got it?
But I
Yes,
think
yes,
they have incremented 1 just because 4 has caused this event. Just due to that, it became 5. So that's what I was thinking. It will
Yes.
compare 2 plus 1, 3.
Correct.
And here it will be 2. So 2 comma 3, what is the maximum? 3. So they have put it 3.
Yeah, yeah, yeah. Your point makes sense. Yes, you are right.
Yeah. So
So
this was
there was no timestamp for this event. When this event happened, the local timestamp was set to 1.
yeah.
Correct. And
So,
this timestamp.
yeah, so the local logical clock here was 2, as per like when this event was about to occur. So it will be
One,
like 2
one,
just
one,
because of
one,
that event. And
one, one,
just
one.
no, before that event it was 1, but
Yes.
when the event will occur, just if we will see P2, then it will be 2. But just because this has been caused from 2, it has become 3, so it has compared 2 comma 3, and whatever was
No,
maximum
no,
it
no,
has
no,
gone
no, no,
to
no.
that.
You are taking it as wrong. See,
नहीं नहीं यश
huh?
this is only correct what Gitika is
Okay.
saying. You
Uh,
Yeah.
just go up in the slide. You just go up in the
yes,
slide.
yes.
This CI max of CI comma C message.
Correct.
So max of CI will be 2
Okay.
because here the event is 2. CI
Okay,
is
okay.
local
Tell
to.
me one thing. Tell
Hmm.
me one thing. Okay. Max of CI comma C message. What is the C message? What is the value of
C
C
message
message?
will be 2 plus 1, 3.
C message will be 2 plus 1 3. Are you sure 2 plus 1 3?
Yeah,
Why big? Why?
because from 2, it is going to increase 1,
No, no, no.
because it has to manage its local time, right?
And understand this. In the graph, it is properly written 2 here. That means, see, what we are sending the message plus the timestamp of this value. So the timestamp here is 2. So 2 will be sent to this. Okay, 2 will be sent here, not 3.
Yeah.
Okay, so
Yes.
C message will be 2. Like Mohit, I guess you are asking, right?
It's me, Mohammed.
Mom, acha, ha, Mohammed. So C message will be 2.
Okay.
Is this clear to you?
ठीक है.
Okay.
Okay.
And now, according to your theory, what is the CI here?
CI should be 2.
CI should be 2.
2.
Where did you updated the CI? When did you update in the algorithm? In R1 and R2, where did you update it
No.
for
Yeah, I
process 2?
mean, as per this, the second event should be 1 plus 1.
देखो वही
Just
मैं आपसे
read
कह रहा हूँ.
those lines. Yes, just let's read those lines
Yes,
written.
yes.
Yeah, here.
Hmm.
See, yeah, each message piggybacks the clock value of its sender at sending time.
Hmm.
Two it has sent. Okay.
Correct.
When a process PI receives a message, P2 has received the message with
Correct.
timestamp C message, that is 2, right?
Correct.
It
Correct.
executes the following action:
Hmm.
CI maximum of CI, comma C message, execute R1. R1, what R1 says, increment it with D,
हाँ.
right?
So tell me.
CI was
Okay,
1,
stop here only.
and
Stop here
C
only.
message
Stop here
was
only.
2. Yeah, yeah, just a minute,
Okay,
let
okay.
me complete
Okay,
that.
okay, okay, okay.
CI was 1 and C
Hmm.
message was 2, so whatever was maximum, it was 2 was the maximum. So
Exactly.
it executed R1 and it made it 3. It's
Exactly.
2
This
plus
is
1
this is
is
now the correct you are saying.
mm-hmm.
You understood now?
Yeah. So, but here, what is happening is, for example, just I was thinking, if there would have been one process 2 as well at P2, right?
Okay. Okay.
Then again it will compare 2 and 2 and it will be 3.
Yes. Yes.
Mm-hmm.
Understood. For example, if between 1 and 3 two events have occurred, then it will compare between 2 and 3, and then it will be 3 plus 1 4.
So we can think it like, we can remember it like whatever is the maximum number process on
Yes.
P1 or P2, right?
Yes. That's
Yeah.
what is it.
Mm-hmm.
Mohammed, you understand
Previous
this?
event. Mm-hmm.
समझा भाई
भाई
समझा. Yeah, I
मुझे
understood that.
समझ
कंफ्यूजन
गए?
आ गया.
Yeah,
एक बार
that's
So
what
I
दोबारा
I
was
was
समझाना.
thinking
trying.
like that event is
नहीं
for
नहीं नहीं नहीं
that particular process
नहीं.
also. So it will increment for that, as well as it will check for the message which is coming from the other process, and then it will compare which is the max, and then
No, it will occur. Yeah, you are correct. It will occur in sequential order, but the sequence
hmm.
is first compare the max value
Okay.
and then
Hmm.
increment it.
Right.
Because जब तक
Okay.
acknowledgement नहीं आएगा तब तक हमारा data update नहीं होगा ना. That is the only
Okay.
thing.
I was thinking it will increment and then
नहीं नहीं थोड़ा सा वहाँ पे
see.
glitch हो गया था.
Okay.
Okay, Gitika, is it clear?
हाँ, मतलब लास्ट प्रोसेसेस में जो भी मैक्सिमम है उसको लेके हमें +1 करना है,
हाँ,
whether it
correct,
is on P1 or whether it is on P2.
correct, correct, correct,
Okay.
correct.
ठीक है.
ठीक है. जैसे यहाँ पे देख लो आप ये वाले इसको देख लो एक बार. ओके, दिस व्हाई दिस केम एज 8 बिकॉज प्रोसेस P1 का तो इनिशियल टाइम स्टैम्प अभी करंट टाइम स्टैम्प वैल्यू 3 ही था, बट फ्रॉम हियर इट वाज कमिंग 7. सो आउट ऑफ 7 and 3 which one is maximum? 7 is maximum. That's why 7 plus 1 is like, that's why the timestamp will be 7, and then we will execute R1 process that is incremented by 1 unit, and hence it will be 8. Got it?
Perfect.
Perfect, perfect, perfect. Okay, guys, I think many of must have left. Yeah. So other than that, guys, is it everything is clear to you all? Chalo.
Yes.
Guys, request Harshal और क्या है ना प्रसन्ना भाई रिकॉर्डिंग शेयर कर देना यार, बहुत दिक्कत हो जाएगा वरना. ओके,
हाँ भाई कर
चलो.
देंगे.
Thank you guys. Thank you for attending the class. Like I'll
Thanks,
be
Yash.
back with new chapter maybe tomorrow or day after tomorrow when I'll be I'll understand everything. Chalo, bye bye, good night.
Thanks,
Bye.
bye.
Good
Bye
night.
bye.
Good night.
Good
Bye.
night.